For problem number 6 instead, which of the following conclusion can be drawn from J.J. Thomson-Plum's pudding model? Atoms contains electrons. Yes, we know that. Actually, Thomson is the one that came up with the cathode ray experiment. B, practically all the masses in an atom is contained in its nucleus. Well, Thomson doesn't talk at all about the nucleus. He doesn't know. Atoms contain protons, neutrons, and electrons. He doesn't even know the presence of neutrons yet. Atoms have a positively charged nucleus. He doesn't know nucleus. No two electrons in one atom. They don't have anything to do with the Pauli exclusion principle. Therefore, A is the only possible choice. For all those questions 7 through 9, those are the clues that you have, the choices that you have. And so for number 7, explain the spectral lines by postulating the electrons were only able to exist in discrete orbitals, different energies, that's Bohr. 8 describes the location of electrons series. This is actually the quantum numbers. And 9 caused by electron emitting energy as they transition from one specific orbit to another, and those are the spectral lines that are caused by this electron moving and stuff. Which of the following is a correct interpretation of the results of Rutherford's experiment? Atoms have equal number of positive and negative charges. Is now coming from the experiment of Rutherford. Neutrons are at the center. He doesn't know about neutrons. Neutrons, again, he doesn't know. Positive charge of an atom is concentrated in a small region. Yes, that's what he has seen with the alpha particles, because remember, those alpha particles were shot against the gold foil, and because of the detector, it was possible to see where those alpha particles would bounce. So either they went straight through if they found no encounters of protons. Otherwise, if it was a head-on collision, those alpha particles would bounce back. So this is the reason why he knows that there are nuclei at the center of the atom. For number 11, the energy of a photon of light is blank proportional. Oh, okay. So you know that the energy is equal to the quantum number h multiplied by the frequency. So is proportional to its frequency, so directly proportional to the frequency, and inversely proportional to the wavelength. So direct inverse, so D is your choice. What is the wavelength of light? Now, in this case, you got to do some calculations instead. So you have frequency of 3.22. So let's see if I can write it there. So your frequency is So your nu is 3.22 times 10 to the positive 14. And those are hertz. And they want to know the wavelength. So you know the wavelength is equal to C over nu, and you know the C is 3.00 times 10 to the 8 meters per second divided by 3.22 times 10 to the positive 14, 1 over second. Second and second cancel out, so your answer is going to be in meters, which is what you want. So you have a 3E8 divided by 3.22 E14, and you have a 9.32 times 10 to the negative 9 meters, or 932 nanometers. So let's see which one is your possible choice. So this would be the one, right? D. Oh, they want it in nanometers, so 932. So A is your choice. The energy of a photon that has a wavelength of 9 meters is how many joules? So let's move ahead. So the energy is H times nu, but you have lambda, so you got to calculate nu first. And this is C divided by your lambda, so the C is again 3.00E8 divided by, what was it, 9 meters. So that will give you, so 3E8 divided by 9 is going to be 3.33E7. 3 times 10 to the 7th hertz. And your energy is going to be 6. So this is 6.636 times 10 to the negative 34 multiplied by the 3.33 times 10 to the 7th, and your number is 2.21 times 10 to the negative 26 joules. And 2.21 in negative. Okay, so A is your answer. Then for periodic table, which pair of elements would you expect to exhibit greater similarity? So they have to be the ones that are in the same vertical line. So those are the only two. So oxygen and sulfur. And then 15, an element that appears in the lower left corner, okay, is either a metal or metalloid. Is definitely a metal, right, because of those trends for the periodic tables. And then the element in group 117, those are the alkali. So this is the alkali metal. 17 are your halogens, and 18 are your noble gases. So it has to be C. 17, which of the following is most likely to lose electrons when forming ion? Well, those have to be the elements at the beginning in the, what is called the alkali metals in particular. Now, out of those, you have fluorine, which is willing to take 1 electron because it's halogen. Phosphorus needs only 3 more electrons. This is the only metal here, because then you have sulfur and nitrogen, so C would be a perfect one. 18, when a metal and a non-metal react, the blank tends to lose electrons, so it has to be the non-metal. The metal tends to lose electrons, and instead the non-metal tends to gain it. So metal and non-metal, so C. 19 typically forms ions with a 2+ charge. That would be the alkali earth, because it's like calcium and so forth. Chemical names and formula. What is the ratio of hydrogen to oxygen in the mineral? So the oxygen to hydrogen. So you have 3. So how much oxygen you have? You have 12 here, 3 here. So 12 and 3 is 15, plus 12 there, so you have 27. And the hydrogen instead is 3 and 24, so 27.